You guys that have already fooled with some cylinder heads have seen valve stem seals, you know, around the stem of the valve. You got seals on the intake and exhaust valve. The intake valve is more prone to give trouble with oil leaking past it than the exhaust valve, because there's a low air pressure in that intake, and it can pull that oil down in there when the engine's running. So you got with that low pressure in there, and when you park this thing, you shut it off, let it sit, and that oil gets down in there, and then when you crank it up, it pulls it into the cylinder, and it makes white smoke come out and go all the way across the parking lot. This thing right here was a 2002 Camry with 94,000 miles, 2.4 liter engine, and it had that transaxle in it. Who cares? And that's the car. That's what it looked like, right? Okay. This particular one, it always smokes on startup after a soak. Now we had done these before, and so we were set up to do another one. And there it is. That's your little VVTi engine in there. All right. Your valve stem seal problems have been around as long as overhead cam engines or overhead valve engines have. The ones that had the valves in the block didn't have that problem because they didn't need seals on them much. But this particular one, if you ever seen like all these spark plugs, you'll see some really thick, puffy deposits on the spark plugs that look like ice cream or something almost. And it's real hard. That's typically from valve stem seals. If you see that, that means the valve stem seals are leaking. Doesn't mean you need to down the car and put seals in it right then, but it does mean you got valve stem seal problems. If you get a puff of smoke, or if it's idling a long time, you may see it start puffing smoke out the back if the valve stem seals are leaking pretty bad. And some of them, you know, whenever you crank them up, like Alan Cobb had that little 93 Camry, it was the first one I did this operation on, and this thing would just fill the whole parking lot up with smoke when you crank it up after it sat there for a while. And of course it had a lot of miles on it. This one here did the same thing. We did this on a 2003, we did it on a 2002, we've done it on some others. And the intake valve stems got low vacuum applied to the pressure, to the bottom end of it, and that valve stem seal, when they get hard and they start to wear, you can pull it in there. All right, that's what a valve stem seal looks like. But one of the ones that we changed out on this one, it's got a little garter spring around there. Now we sort of damaged it a little, jerking it out with pliers, but that was a really hard valve stem seal. It's a little tiny thing, not very big. That little hole is only about a quarter of an inch in diameter, or about 6 millimeters if you go that route. So I have seen them leak so bad that they would make the oxygen sensors read wrong and foul up the mix on the car. And also, if you got a lot of those puffy deposits on the plugs or something else fouling them, sometimes you'll have what's an EGR surge. You unplug the EGR valve, it clears up. Doesn't always mean your EGR is a problem. It can just mean you got partially foul spark plug. All right. You can have, when I called the dealership to ask them about it, I said, how do y'all handle this? They said, we pull the head off and send it to the machine shop and get a valve job done on it and let them put the seals in it, and then we bring it back and we put the head back on. Well, that's 17 hours labor. That's a $2,000 repair. But what we did doesn't take as long, it's not as hard, and it gets the same job done as far as replacing the valve stem seals. Okay, now this particular deal here, on the back of the head over there, down there, you got to pull this little tensioner out. See it right up there? That little tensioner. That's the tensioner partially removed right there with a gasket around it. And then you have to take these, you're supposed to line it up where the timing marks are. We'll talk about that in a little bit. That wire harness is kind of in the way, but you can get that tensioner out of there. It's not all that hard to do. You pull the bearing caps off, make sure you got the timing marks all lined up to start with, and once again I'll show you that close to the end. You know, pull those camshafts out. They got to be out of the way because you got them cam followers underneath, right? This is a tool I built. I bought this. This is a TOY 165 from the Mac tool man, or actually AST is the tool company that makes it. I haven't been able to find one since then. So the simple fact is, I got this plate, and it bolts on there so it's kind of loose and it can whirl around any kind of way. I cut this C-clamp, which was bent anyway, and then I welded a socket on here so that you could use this to squeeze the spring down and get those seals out. See how that's the thing in use. Now I've got this bolted down to the flat part. You just have to put one bolt in it, then one of them cam saddles. And you tighten this down, that squeezes the spring, and you reach right through here, get those keepers out. And there's your valve stem seal right there, down at the bottom of that well. Now this cam follower that was sitting on top of the valve that fills up that hole had to be removed. When somebody does a valve job on one of these, what has to happen is the place between the smooth polished top of this and the part that sits on the valve, all those spaces are different based on what's required in order to put the right distance between the cam lobe and that follower. So that all of that stuff's got to be done if you're doing a valve job. This way you don't have to do all of that. And you pull that stem, that seal off, you put a little plastic sleeve over there that usually comes with your valve stem seals. You slide that valve stem seal down over there, you know, punch it down into place with a socket or something, and put all of it back together using the same tools. Now you got to put it back together and time. See the links we painted yellow? It's going to tell you how many links is supposed to be between there. And there's a mark here, and obviously this right here is the mark on the one with the variable cam timing deal. And then you got to latch that with a little, this funky little thing here. You push that. This is the cam. The tensioner, oil fill tensioner. Oil pressure drives it.
Most chains have those on there?
Huh?
Most timing chains have those on there? The marks, or?
Well, when you buy new ones, they'll have different colored links.
Oh.
Yeah, it'll either be copper or shiny or something like that. So yeah, you're right. Now look at this. See that little tiny arrow right there that's really hard to see? That little arrow right there, if you're not looking for it, you'll miss it. But that's the timing mark on that cap. So you line these up with those arrows. There's one on both sides. There's one here, there's one over here. You can see that one if you could look real close and zoom in. And then you got it down on the bottom, you got to have that on 0. That's not exactly on 0, but it should be. But you can see what I'm talking about. Obviously that one needs a bell. And that's the end of it. See, I did not give you a comprehensive, this is exactly step by step how you do the whole thing, but you get the idea. And the whole point is it can be done. A lot of the stuff that other people, I'm a sort of an unconventional thinker, and a lot of times I'll do stuff that other people won't even try to do just because I feel like I can. And it's really surprising how many times we can make this sort of stuff happen, you know, if you just have the right attitude, you know. All right, let me click out of that and turn that thing off. Now let's jump into this engine repair 2 test 8. We're basically talking about emission control devices in here, which is, we're also teaching emissions this time. 2 technicians are discussing clogged EGR passages. Huh? Hurry up. I'll be 3 questions in by the time you get back. 2 technicians are discussing clogged EGR passages. Technician A says clogged EGR passages can cause excessive NOx emissions. Is he right? Yep. Technician B says clogged EGR passages can cause the engine to ping. Is he right?
Yeah.
How come? Why would it ping? I'm not saying you're wrong. I'm just saying, why would it ping?
Well, take it true. I don't know ping.
Labor knock. I mean, it basically sounds like you got marbles rattling around in there. And it's an unusual sound. Anybody that's heard it will remember it, but it's a pinging sound, and there's no other way you can describe it except ping. Ping, detonation, you know, spark knock, all the name. You can hear it. If you got bad gas, it'll do it, because bad gas is really explosive and burns really fast. But anyway, here you got your combustion chamber temperature. It goes over 2,500 degrees, you can have detonation. That can cause it. Usually it won't, but it can. An EGR valve that's partially stuck open would most likely cause what condition? If the EGR valve is stuck open, what's the most likely symptom you would have? Rough idle stalling. Good answer, Brian. How much air flows through the PCV system when the engine's at idle speed? Now that's a tough question to answer if you didn't read the chapter, isn't it?
10 to 20%.
Actually, it's up to 30%, believe it or not. That's how much air flows through the PC. How much of the air flows through the PCV system when the engine's at idle speed, and that's metered air too, because the other side of that PCV system is connected into the air hose, usually going to the engine, because it needs filtered air. Technician A says if a PCV valve rattles, then it's okay and does not need to be replaced. Technician B says if a PCV valve does not rattle, it should be replaced. Which technician is correct?
A.
Anybody else got a question? What about B? You can actually rattle a PCV valve and it still need to be replaced, because it can have a broken spring in it or whatever. Here's something else you need to recognize too. When you get a PCV valve for one, make sure you get the right PCV valve, because the orifice and stuff that the air pulls through is different sizes. And if you put the wrong PCV valve on one, you can cause it to pull too much air and make fuel trim issues. Imagine some yo-yo putting the wrong PCV valve on one and you're chasing a fuel trim problem, it's just driving you crazy. because he put the wrong PCV valve on it. I've seen that happen. You know, make sure you put the one on there that is calibrated for that particular vehicle. We don't usually think about that, but I've run into it in the field. Two technicians are discussing a catalytic converter. Wait a minute, I'm sorry. The switching valves on the air pump, the air injection reactor pump, have failed. As a matter of fact, that's what General Motors calls that, air injection reactor. Ford calls it thermactor, you know. But anyway, Technician A says that defective exhaust check valve could be the cause. The check valve is basically used in low pressure exhaust pulses that are naturally there, you know, to help work that air into the exhaust whenever it's going back to the catalytic converter to help it work right. But anyway, Technician B says a leak in exhaust system at the muffler could be the cause. Okay, so who's right? A is the only person that's right about that. A leak in exhaust system at the muffler is not going to make that thing die. Those switching valves are plastic anyway, and if there's exhaust coming up in there, it melts them down. That's what he's talking about. And that little one-way valve is supposed to keep that hot exhaust out of there. Two technicians are discussing testing a catalytic converter. Technician A says a vacuum gauge can be used and observed to see if the vacuum drops with the engine at 2,500 RPM for 60 seconds. Technician B says a pressure gauge can be used to check for back pressure. Who's right about that? So how do you use a pressure gauge to check for back pressure? You screw the oxygen sensor out of there. You screw a fitting in there. You can put a hose on. You put a gauge, a pressure gauge on there, and you shouldn't have no more than about a pound or two of back pressure. Now, some of the people at some muffler shops I know about will take a 1/8 drill bit. They'll drill a hole in the exhaust right in front of the catalytic converter, a little tiny hole, and then they'll take a hose that's cut off flat that's hooked to one of these. You know these gauges like this one right here? See this gauge here? Everybody look. Everybody look at me. You see this gauge here? You hold that hose up against that, you know, take that cone off there, hold that hose up against that exhaust. You'll be able to read your exhaust back pressure there if you drill a hole right in front of the catalytic converter. All right, another way you can check it, and this is not an accurate way. The most accurate way is to check the pressure in the pipe between the engine and the catalyst. If the pressure is more than a pound or two, you got a restriction in your catalyst, in all likelihood. Now the muffler can have baffles break loose in it and stop the exhaust up too, but that almost never happens. Usually it's the catalytic converter honeycomb stopped up. Yeah, I have actually taken the temperature gun and I've shot the exhaust in front of the catalytic converter and I've shot it behind the catalytic converter. And that is another accepted way. I didn't come up with that way, but I have seen that way fail to detect a bad catalytic converter. Low power vehicle, won't hardly run, shoot it in front, it was reading about 195, 200 degrees, shot it behind, it's reading about 400. That's what it's supposed to read. Listen to me, burn that in. It's supposed to be cooler in the front of the catalyst than behind it, right? Now if it fails that test, the catalyst is done. If it doesn't fail that test, it doesn't necessarily mean the catalyst is good. You get where I'm going with that? It can fail that test and condemn the catalyst, but if it passes that test, that doesn't exonerate the catalyst from being a problem. That's the same way with checking, using that little meter there to check the diodes on the alternator by going to the big wire in the case and swapping them around. If it fails that test, you're done. If it doesn't, you may still have problems. You understand what I'm saying? A lot of our tests are like that. But anyway, about what temperature does oxygen combine with the nitrogen in the air to form NOx? I've told you this before. What is it? 2,500. That's a good answer. PO 401 diagnostic trouble codes being discussed. Technician A says a stuck closed EGR valve could be the cause. Technician B says clogged EGR port could be the cause. What do you think about that? Either one. And clogging EGR ports are really common.
Is that either or neither?
Both of them. Both those guys are right. Which evap valves are normally closed? Canister vent, canister purge, both canister purge and vents, or neither canister purge nor canister vent valve. One of those valves is a normally closed valve. The canister purge valve. The canister vent's normally open because it needs to vent, unless it's being told not to during the enhanced evaporative system test. Number 10, before an evaporative emission monitor will run, the fuel level must be where? Anybody remember that? I've said it before.
Over 25%?
Actually, between 15 and 85%. Like on my wife's Explorer, I don't imagine it's probably had an evaporative test since who knows when, because she always keeps it full. If it gets down to almost to 3/4 of a tank, I'm going to the gas station to fill it up for her. And she will not have, you know, gas even hardly. Why is that a good thing? I'll tell you why it's a good thing. Because you don't have condensation with getting water in your gas that way. If you're always running it empty, you're going to have condensation. It's going to gather in the bottom of your tank and a host of other problems. But if you're running always real close to empty all the time, you won't ever do an evaporative test either because it was just not accurate either way. The purpose of the evap system is to trap gasoline vapors, also called what?
B.
C.
C. VOC, yep. I always call it that they're hydrocarbons, you know, it's vaporized hydrocarbons are what they are. Technician A says a carbon charcoal canister, you know, charcoal canister, is used to trap and hold gasoline vapor so they can be purged and run into the engine and be burned. Technician B says the purpose of the evaporative emission control system is to reduce the release of volatile organic compounds, which is what VOC stands for, into the atmosphere. I don't know why they have to come up with an acronym, or doesn't spell a word, so it's not an acronym, an abbreviation like that. VOC, you know, which technician is correct, and that's going to be C, both of them. All of these can increase the pressure in the evaporative emission control system, except for what? A, read vapor pressure of the fuel. B, inlet fuel to the return pump. Inlet fuel to the fuel pump. C, return to fuel from the fuel injection system. Or D, fuel temperature. Which one of those cannot increase the pressure in the evaporative control system? And that would be inlet fuel to the fuel pump, because that's got nothing to do with the evaporative control system. Which of these substances used in vapor canisters can absorb volatile organic compounds? Anybody know? We got to have something that can absorb them. Carbon. Why?
What do you mean?
Well, why is the answer carbon instead of organic absorber, pleated paper, or desiccant?
Well, 'cause it's
What
carbon
are
canister.
what are the volatile organic compounds?
I don't know.
Carbon. So you're going to use carbon to absorb carbon. Didn't you take chemistry in high school?
No.
I didn't either. Okay.
I mean, I guess it-
You did take chemistry, but you forgot it.
yeah.
Well, that was 10 years ago. I can understand why you'd forget it. Okay. But anyway, you use like things to absorb likes. If you're gonna wash grease off your hands, what works better than anything else?
Soap and water.
Transmission fluid.
Soap and water does not get grease off that easy.
Yeah. But I mean, if you use transmission fluid to wash your hands, it's just as clean. Or you can wash them with gasoline or something like that. You know, you can actually make it hot, and the soapy water will kind of do stuff. But one way or another, likes dissolve likes, right? The best hand cleaner that they used to make, the old Gojo stuff, you know, would get that stuff off your hands really well. Okay, let me see here. I remember that too. I remember the smell of it at my dad's shop back in the early 60s. You know, I thought that Gojo smelled so good. But anyway, let me see, where are we at here? Technician A says, the EGR, exhaust gas recirculation, is not usually needed at idle and not wanted at wide open throttle for maximum engine performance, or when the engine is cold. Technician B says oxides of nitrogen are formed inside the combustion chamber due to heat exceeding 4,500 degrees. Well, that guy's a yo-yo at 2,500. So that's going to be A only, and exhaust gas recirculation is generally not needed under all the following conditions except. It's generally not needed. When's it not needed?
Idle speed? No. Cruise speed.
It's not needed at wide open throttle. It's not needed at idle speed. It's not needed at cold engine, but it is needed at cruise speed. That is a screwed up question. I don't like the way it's worded, but A is the right answer, and you can understand where they're coming from if you think about that. But we can read that question quick. You'd have to go back and read it again and think about it. Technician A says recirculating 6 to 10% of inert exhaust gases back into the intake system increases peak temperature inside the combustion chamber and reduces NOx exhaust emissions. Technician B says vacuum operated EGR valves are usually back pressure controlled to help match EGR flow to intake with the load on the engine. Who's right about that? B is right about that. Got it? Technician A says many EGR systems use the feedback. Well, see, the 6 to 10% is obviously, you know, what they're doing. I mean, that's the number that fouled that question up. and that's difficult to parse. Technician A says many EGR systems use a feedback potentiometer to signal the PCM about the position of the EGR valve pedal. You seen that? The GMC has got one like that. The Oldsmobile's got one like that. There's a lot of them out there that are set up that way. Technician B says some EGR valves use solenoids that are pulse width modulated to control the pintles. Both those guys are right. And we got 2 more questions left before we bail out of here. What causes the nitrogen and oxygen in the air to combine and form oxides of nitrogen? Somebody tell me.
B.
Which one?
B.
B, and that is heat above 2,500, right? Which is, how much is that in Celsius?
1370.
Okay, hey, did you see how fast he figured that? He actually looked at what was in the parentheses, didn't he? If something's 40 below degrees Fahrenheit, what's that in Celsius? Anybody know? 40 below Fahrenheit is what in Celsius?
20.
What's 40 below Fahrenheit in Celsius? I saw a yawn.
20.
I'm only going to say this one time. It's going to be on a pop test. It's 40 below. 40 below Fahrenheit is 40 below Celsius. They're the same. That's where they cross. Got it? Do you all feel silly now? Not really, I don't guess so. Okay. All right. Exhaust gas recirculation is used to control what? And that's our final question for today. Do you need a lifeline?
B.
NOx. Why do they call it NO with a little X? Anybody know?
Nitrogen.
Because that X can be any number.
What was 8?
8?
C.
That's both of those guys could be right
What
about
was
that.
6?
Huh?
6.
C.
No, 6 was C.
What was 1?
1? Where were you at? Okay.
Yeah, go get his pencil. You told him you were going to pressure his green.
Well,
I
no,
get back.
Yeah. Huh?
No.
Which evap valves are normally closed? Somebody? Huh? Yep, there you go.